Greetings, students. This is a recording to help if you missed the Parabola quiz at the beginning of Unit 2 in Algebra 2. So at this point, this is really kind of hard to see, but this is what your page looks like. We are going to answer those questions, but I'm going to zoom in on the parabola so that we can see that better as we work through to answer those questions. All right, so I'm going to write my answers kind of over to the side, but you can write those below on your paper. So again, this is the review, and this should be helpful as you get ready for that quiz. So number 1, ask what is the vertex? So remember, the vertex is the turning point of the parabola. So this down here, that would be my vertex. That point is the vertex. And so the vertex is an ordered parabola review. Take 2. Got through the first page and realized I hadn't been recording anymore. So here we go again. I guess I didn't have to confess that mistake, did I? Anyway, your questions are below, but I'm going to write them up here so that we can see that parabola as we work. So the first question asks about the vertex. The vertex is the turning point of the parabola. So right here, and it is a point. So we need to give the coordinates for that point. The x coordinate first, and then the y coordinate. So the vertex, we need an ordered pair. It's like the directions from the center, how to get there. Our axis of symmetry, remember that is like where if we were cutting out a heart, and we folded the paper, the fold is the axis of symmetry. So we are used to having like some formula for that, but this time we're looking at a picture. So if I look at this picture and I think, where would this be folded in half so that it has a mirror image on the other side and it would be symmetrical, would be that pink line that I just drew. So that axis of symmetry for a quadratic function will be a vertical line. The equation for a vertical line is always x equal. And then what does x equal every place on that pink line? -2. And we should see that that matches the x of our vertex. You do need x equal because it's and I tried to remind you by telling you what is the equation. So an equation has an equal sign in it, so it can't just be the number -2. So number 3, what is the y-intercept? Where does it cross the y-axis? In this case, it crosses the y-axis at 0. Okay, so we could, because it is y-intercept, just like this is like saying what is the b if we were making a straight line. What is the b? We could simply say 0, or if you prefer to give it as an ordered pair, since it is a point on the graph, it would be 0, 0. Anything on the y-axis would have a 0 for x. And then for our x-intercepts, do you see that? That S isn't a mistake, it's plural, because there are 2 places that the parabola crosses the x-axis. We could say it crosses at -4 and 0. Those are the 2 x values where it crosses. Or we could say 2 points, -4, 0, and 0, 0. If you just write this as an ordered pair, that looks like you're just describing the point on the left, right? So can just list the two x values, -4 and 0, or if you're going to do ordered pairs, then you need two of them because there are 2 points where it crosses. And then next we have what is the domain. So we want to think about what x's would be used, and I see that there are arrows, so this parabola is stretching up, but it's also stretching to the left and to the right. See how it's getting wider? And so that means eventually it would get to every x to -infinity and every x to +infinity. So we could say that that is all real numbers. So you can do this fancy double-barred R. It's just a shorthand way to write all real numbers. You could write the words all real numbers if you like. Or if you choose, you could use what is called interval notation. And in upper level math classes, you will see that often. So -infinity to +infinity, that's interval notation. All three of those things say the same thing. And then number 6, that was the domain. Number 6 is asking us about the range. So if the domain had to do with the x's, yeah, the range has to do with the y values. So I see that those are going up, 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 up. So they would continue up that way. But all of the parts of the graph down here, and if the graph was bigger, none of those values for y would ever be used, right? Because this is the lowest point we had there. So none of those values at the bottom would be used. So it's definitely not all real numbers then, because it's not stretching out down to the bottom, it's only stretching up top. So we could say that the y values are greater than or equal to -8. So from -8, which is our vertex y, and up. So that's one way to write that. Or in interval notation, we could say from -8, we use the hard parentheses because -8 is included, all the way to infinity. We never use hard parentheses with infinity. So that just means it goes up forever that way, but it doesn't go down forever, only as low as -8. And then last is, does it have a maximum or minimum? And in this case, it has a minimum. That -8, that lowest value it has, means it has a minimum. It does not have a maximum value. It just keeps going and going and going. All right, page 1 is done. All right, on page 2, next up, we have a multiple choice question, so please don't try to make that into 2 problems. And we are supposed to circle the correct vertex. Now, just because it's multiple choice doesn't mean we should just be able to look at it and know. We still, in this case, need to do some work. So you want to think first, is the equation in standard form? Remember, ax squared plus bx plus c? Or is the equation in vertex form? Vertex form, if you looked at your reference sheet, you would see there are some parentheses. And I don't see any parentheses, so I'm going to go with standard form. Standard form for the win this time. So if it is in standard form, remember to find the vertex. Step 1 is we need to find the axis of symmetry. And we use this little formula, -b over 2a. So -b in this case, this is -8, right? So it really means like switch the sign, and 2 times -2. So it does not just mean that b is negative. In this case, b is already negative, but then this is -b, or like -1, or the opposite of b, which is why the top becomes +8, and then the bottom is -4, and then we actually can divide that. So 8 divided by -4, x is -2. So that gives me part of my answer. So I now know it's not those first two. And so now remember to find the y of the vertex. So step 1 was to do your axis of symmetry, because that's the x of the vertex, and then plug it in to find y of the vertex. So now I'm going to be putting -1 in for every x. So I have -2, and then here where the x is, I'm putting -2, sorry if I just said -1, squared minus 8 times -2 plus 5. So that's the -2x squared minus 8x plus 5, except that now everywhere there was an x, I have replaced it with -2. And you could type that into your calculator just like it is, or work it out on paper. But remember that that exponent happens first, and that is a +4, since two negatives, when we square it, become positive, right? And then I'm just going to rewrite this part for the moment. Now I'm going to do my multiplication. So -2 times 8, or -2 times 4 is -8. -8 times -2, +16, and plus 5. Now it's just adding and subtracting, so we'll just go left to right. -8 plus 16 is 8, and 8 plus 5 is 13. Ding, ding, ding. So we celebrate because we see our answer as one of the choices. And then for number 9, it is just an or question. Would this have a maximum or a minimum? So think about what it would look like. It has a -a, which means it's going to open down like a frown. And if it's opening down, it has a maximum. So when the a number, the coefficient of the x squared, when that is a negative, the parabola has a maximum. And if it was a positive, yes, it would have a minimum. All right, a couple more done. So I hope you notice that this question is again a multiple choice question, but this time it is not in standard form, right? There are no parentheses in ax squared plus bx plus c. This is in vertex form. And as a reminder, and it is on your reference page, but vertex form looks like this. Commonly spotted because of the parentheses. And if it is in that form, then HK, also on your reference page, is your vertex. Notice, because there is a minus with H, that we always change that sign from what we see. So I see -4, so that means 4 is actually H. And then the guy on the outside stays what he is. So 4, 5. So that one, there really isn't a lot to do. It's called vertex form because it's super easy to find the vertex if it's in that form. So 4, 5. And then would this parabola open up? So would it be opening up like a smile or down like a frown? Again, that answer lies in the A. And this time the A number is positive, so it opens up. Which would mean it has a minimum, but that's not what you were asked. You were asked up or down. So in this case, up. So far, so good, I hope. All right. So the next couple pages, we will actually be graphing a couple parabolas. So give me a second here. We'll have to figure out what that is going to look like. So I'll fill in the questions and then we'll go down to make the graph after we fill in the questions. So ask yourself first, is this vertex form or is this standard form? It's vertex form, you're right. So when it is vertex form, x equal, and remember this one always changes because the axis of symmetry is just the x part. And it's an equation, that's why a lot of times I just put axis of symmetry, but I don't want you to forget the x equal, so that's why I added equation of the axis of symmetry. The vertex, -3, -4. Will it open up or down? Well, the A is 2. That's positive, so up. So in vertex form, the A is the one in the front of the parentheses. What about the domain? So we don't have a picture this time, but is there any number that you can think of that like we would not be allowed to use for x? Positive numbers okay? Negative numbers? Fractions? They might be messy, but we can still use them. So the domain is still all real numbers. And if you choose, you could, again, write that in one of the other ways that I showed you before, like in full out words, or if asked to give interval notation, that would be your interval notation. And then our range, we don't have a picture, but we know where the vertex is, and we know it's opening up, and it opens up, then we know our y is greater than or equal to, and we use the y of the vertex. Or we could say from -4 to infinity. All right, so now we're going to take that information and start making our graph. So some of that information is like we already have part of our graph, but we're going to repeat it. We're going to use that vertex as our first ordered pair in our table. So I've given you the equation again, but let you know that this is the same one as above, so you don't have to start recreating the wheel. So this was -3, -4, and our axis of symmetry was at x is -3. So we will trace down at x is -3, -3, -4, would be here. And then we need, I'm going to do, it says make sure there are at least 3 points in the table. If you choose, you can do more. I'm going to do the next 2 points to the right and then use the power of symmetry and do the mirror points on the left. So if I'm going to go to the right, I'm adding one or going, like on a number line to the right. So I'm going to use -2 and then -1. And then we have to actually place them in the formula to find the y. Only the vertex is the super easy one. So 2 times -2 plus 3 squared, take away 4. So it's important that we follow our order of operations. So -2 plus 3 is 1. The next thing we're going to do is 1 squared, which is 1. So then I have 2 times 1, take away 4, so 2 take away 4 is negative 2. And you could have typed that original part in the calculator, or you could have done probably that in your head without writing so much down. But even if you do it in your head, you need to make sure that you are following the correct order of operations. And then we're going to go through that same process, but with negative 1 as our x. In vertex form, there is only one place to plug in the x, but then it's, got its own complications. So then 2 squared minus 4. So I did what's in parentheses. Then I'll do my exponent. 2 times 2 is 4. And then 2 times 4 is 8. And 8 minus 4 is 4. All right, so I have 2 more points in the table. So negative 2, negative 2. So when I'm using those points, I'm counting from the origin, 2 to the left and down 2. 1 to the left and up 4 for negative 1, 4. Now we're going to mirror those across the axis of symmetry. So the vertex doesn't have a mirror point. He's on the axis. But this one who's down at negative 2, he's 1 space from the pink line, so 1 space to the left of the pink line will be his mirror point. The one up here at 4 is 2 places to the right, so 2 places to the left of the axis of symmetry. Now we'll just try to round that out. Sorry about my scribbly mess there, but I think you get the picture. Oh, mercy, it's getting worse instead of better. All right, so one more graph to go, and you'll be through with the review. So this one was in vertex form. Our last one is going to be in standard form. Discard. So once again, we'll answer the questions, then we'll go to the bottom of the page to make the graph. So our axis of symmetry, this is where, again, something on your reference page could be helpful. This is in standard form, all right? So this is in standard form. And in this case, the A would be negative 1 and the B would be negative 2. The C is negative 5, but yeah, I guess I could go ahead and say that too. So if it's in standard form, no parentheses, I can identify my A, B, C values. And then axis of symmetry, remember, as always, x is negative b over 2a. So the opposite of b, so it's already negative 2, the opposite of that, or think of multiplying it by negative 1, would be 2. And then 2 times a. So 2 times negative 1. So 2 over negative 2. So x is negative 1 is my axis of symmetry. And once you know that, you know half of your vertex. So you can go ahead and plug in negative 1. And then just what I just said, we're going to plug in negative 1. Be really careful here. This is a negative out front. And then negative 1, use those parentheses, is getting squared minus 2 times negative 1 minus 5. I don't always personally use the parentheses, but I know my rules pretty well, and so I do a lot of things in my head. But the parentheses are going to help you realize that you are squaring the negative 1 and getting positive 1, and then this negative on the outside is just falling down, and that's how that turns out to be negative 1. And then these two, negative 2 times negative 1 is positive 2 and minus 5. So let's see, negative 4. So negative 4. Then we're being asked, does this have a maximum or a minimum? Well, the A is negative, which means it's going this way. So it has a highest point. So it has a maximum. Know that negative seems like it doesn't feel like that goes with max, but that means it has a highest point. And the y-intercept. Notice I'm asking you this question before you've made the graph. That means there's a way you can tell without making a graph. So if it is in standard form, the y-intercept is the C number. So the y-intercept is negative 5. Because remember, y-intercept means the x would be 0. And if we made both those x's 0, the only thing left is the negative 5. So the y-intercept is always the C. Sometimes that may be so far at the top or the bottom that you don't actually see it on the graph, but you can tell from the equation what the y-intercept is. Any guesses on that domain? You got it. All real numbers still. So for all our quadratics, x is all real numbers, which is our negative infinity to positive infinity. And you know it, our range is not all real numbers. So we want to think about the fact that this is going down, which means my range is going to be less than or equal to whatever that maximum y is. That maximum y is the y of the vertex. So less than or equal to negative 4. So we could say this goes from negative infinity up to 4. Negative 4, sorry. Up to negative 4. That would be another way to write that. So it's always, when you use interval notation, from lowest to highest. Lowest to highest. So it goes low, 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 low as far as possible, negative infinity, and it has a ceiling. It goes up to only negative 4. That's its max. Right, now we're going to make the graph, and you'll be all set, and I hope ready to take your quiz. Pardon me there. So once again, we need to fill out our table. I expect there to be at least 3 points. If you choose to put the vertex in the middle and do more points, that is your call. But if you do 3 points in the table, and then there should be 5 total points on your graph, because you'll be able to do 2 mirrored points. So we had 1 point already. That was negative 1, negative 4, which was our vertex. And we know that our axis of symmetry is x is negative 1. So axis of symmetry in the house, he's on the graph. Negative 1, negative 4, negative 1, negative 4. So from the center, left 1 and down 4. So there's my vertex. And then I am anticipating it's going to go this way. But let me do a couple points in my table. So from negative 1, I'm going to go to the right. So right one space would be 0. Right another space would be 1. So if I put zeros in, negative 0 squared minus 2 times 0 minus 5, I hope we all see very quickly that all of this just becomes 0. And then 0 minus 5 is just negative 5. So 0, -5. And in this case, all right, then I'm just going to round that out. There we go. All right, so I hope that that is helpful. If you missed last Thursday when we took this quiz, so that you'll be able to watch this and be ready for your quiz. Thanks. Have a good day. I guess every term it would not be last Thursday, but you get my meaning.